right, we are going to start into hypothesis testing. So you may have heard this hypothesis stuff in science and such. So we hypothesize in mathematics as well. We just then see if we can't find mathematical evidence to about that claim. Okay, and what we have going on with that. So let's first kind of talk about the difference between what we just finished, a confidence interval, versus this thing called a hypothesis test. So, a hypothesis test that we're going to learn how to do is basically a yes or no decision saying that we have evidence that to reject the null hypothesis, or we do not have evidence to reject the claim. We have evidence to reject the claim, or we do not have evidence to reject that claim. Okay, kind of like, did you get a sample way far out there? That makes us question the claim. Okay, so then with confidence intervals, okay, so let's remember what those were just this range of plausible values that we're estimating an amount. Okay, so not necessarily giving us a statistical evidence answer. Now, the goal of a hypothesis test is to, well, first of all, with this lesson, we want to get an idea of what this thing called a null hypothesis statement is and the alternative hypothesis statement. And we want to be able to, we'll eventually check the conditions to make sure that the normal model applies. Those are going to be the same things that we have been doing. So that's nothing new. But let's first learn about these null hypothesis and alternative hypothesis statements. Okay, so first, the null hypothesis. The null hypothesis is your claim, the claimed value. It is always setting your parameter equal to that claim. We also will use H with a little o for the null, and then a colon, and then we put whatever it is that we are claiming. So here's an example. HO with the colon, and then you define your variable that you are claiming about. P equals 0.35. So one word of caution, sometimes I get people doing this. HO equals 0.35. So what's missing there? Okay, so we're missing, here's my null hypothesis, announcing my null hypothesis, here's my colon, and then defining the variable, the parameter, P equals 0.35. Okay, so watch out for that. Next, the alternative hypothesis. This is what you suspect or what you are investigating, you think might be happening in general with this problem. So you do not get to say a value like, I don't think it's 0.35 anymore, I think it's 0.32. You don't say that. You don't say, I think it's something else. You only then say, you think it is less than, greater than, or not equal to that claimed value that's in the null hypothesis. So we'll go HA, usually it's H with the little a, sometimes it's with the capital A, colon, and then you say the P is, and then you do these three things, less than, or greater than, or not equal to that claimed value that was stated in the null hypothesis. All right, so you are going to then see, did your sample, was it unusual, and did it give you evidence to reject the null hypothesis and go for this statement in the alternative? Okay, so here's just a little graphic to kind of guide you through that. Here we have the null hypothesis. See, look, H with a little o. This is either P equaling a number. So if we're doing proportion problems, then we're saying we would be defining what that proportion, our problem is about proportion-wise. Or later we'll get into mean problems in the next unit. actually 2 units from now, and unit 8 we will. And then alternatively, we say that the P is any of these things, not equal to, less than, or greater than a number. And then if you have a mean, then you're doing that with that as well. Okay, let's practice. So here we go. We are going to practice stating parameter, the null hypothesis, and the alternative. Now, I have mixed in here averages and proportion problems because this is a time where we can. So be aware that sometimes these will be about a proportion problem, and so you'll be using P and defining parameter, the proportion. Sometimes we'll be talking about an average, so you'll be defining a mu. When you would have the panic model, in the first thing, P, that's when we were defining what our parameter was in context. That's what this is. Okay, so here we go. Number 1, here's our situation. A car dealer advertises that its new subcompact model gets 47 miles per gallon. You assume that the dealer would not underrate the car, but you are suspicious about the claim. You're not necessarily sure if it really gets as good as 47 miles per gallon. Okay? You're pretty sure it's not getting more, so you don't have to worry about that. You suspect maybe it's not 47 miles per gallon. All right, so first, would this be a proportion problem or a mean problem? Okay, so it's about miles per gallon. Hopefully you can tell this is a mean problem because it's not a proportion. Proportions usually have a percentage. Okay, so here we go. So I think it's a mean. And whenever we define our parameter that starts with a mean, our first word is always average. So the average miles per gallon of what population? What are we going to be generalizing to? All such new compact cars, whatever these kinds are. So I use this such to see, like, say that, okay, it's these kinds, whichever kind we're talking about. All right. What would our null hypothesis be? It would be the claim. So don't forget all your little notations and your marks you're supposed to make. So HO colon mu equals 47 miles per gallon. And then you suspected that it's not that great. So HA colon mu is less than 47 miles per gallon. All right, let's try the next one. So read that one and see what you think. Decide proportion or mean, and then see if you can define that parameter. Okay, about the time that it takes to send a package from New York to San Francisco. Now, remember, we don't make a claim about a package. We are making a claim about the proportion of all or the mean of all. We're always making a claim about the all. So, do you think it's proportion or mean? I think it's mean. It says average. Okay, so mean. So, we're going to conclude about what? Now, probably need to say something about it's this delivery service, and it's about the time it takes to send a package from New York to San Francisco. So I want to have those things in there. Okay, let's see. Mu equals average hours or the average time to send packages from New York to San Francisco. Oh, you know what I didn't put in there? And I might should with this delivery service because we're kind of talking about this particular company. We're disputing this company, so probably I should put that in there with this service delivery with this company delivery company. Okay, because I may be disputing, Amazon, not UPS. Okay, all right. What would our null hypothesis be? Get all your notation correct. HO colon mu equals 24 hours. Alternatively, we think we've had several complaints. So Would they be complaining if it took less time? Heck no. So we know that it's going to be complaints if it's greater than 24 hours. So HA colon mu is greater than 24 hours. Okie dokie. Next. Read that one, see what you think. Okay, I think it's pretty clear we're talking average here, and it looks to be set. We are going to be making a conclusion about the average diameter of this type of ball bearing from this machine. Let's see. Average size in millimeters of all such ball bearings. I guess that kind of, see, that's the magic of all such ball bearings. That kind of is like from this company with this type of machine, whatever. But in this, whatever you want to say the specifics are for this. Okay. Average size in millimeters of all such ball bearings. So then what was our HO? That it was 6 millimeters. So HO colon mu equals 6 millimeters. But what about this? Is the average diameter correct? So do we have an indication of a direction greater than or less than? We do not. So we're just seeing, is it one of those ones that's off? Therefore, we can do, this is how you see a not equal to. The average is not equal to 6 millimeters. Okay, you try those next ones. And I'm going to pause right here and let you try those the next ones. How many is there? Is there 2 more? I think. Yep, 2 more. So try the next ones, and then we'll see how you did. All right? So pause. All right. Let's see how you did. So here, oh, look, I see a percentage in there. So that makes me think it's a proportion problem. So that's what I'm going to be defining. Let's see how well you did on defining your parameter. So I think, okay, so this is about heart attack patients who died from any cause after being admitted to the hospital. So within the first 30 days. Okay, so let's see. I want to make sure I got my tense correct also. So let's check. P equals the proportion of all such heart attack patients who die, present or future, not died, from any cause within the first 30 days after being admitted to the hospital. So this is okay because this is my action verb of, well, who die. So I'm talking about current and future patients, about something happening to them. Okay. So the null hypothesis that it is 16.1%, and the hospital is hoping they improved their efforts. So HA colon P is less than 16.1%. All right, and the next one, here we go. I see a percent again, so I'm just finding a proportion. Let's check and see how we did. So this is what's your beat. Make sure you're clear on your denominator. Let's see. This is the proportion of people who undergo this new operation. See, it's kind of an experiment. It's about this new technique. Okay, so that's my denominator. The proportion of people blinded by this particular disease who undergo this new technique. Okay, and who have their, I should just say, who have their eyesight restored. So the proportion of people blinded by this disease who undergo this new technique, because this is an experiment, and the numerator who have their eyesight restored. So currently we know 30% of patients do it, but we're going to see if it gets better, right? So our null hypothesis, colon, P equals 0.30, and then our alternative, HA, colon, P is greater than 30%. All right, I think that's all for today. So you should be able to go through and work on the next, I think it's just the next 2 pages to practice carefully writing your parameter and getting all the notation and on your null and alternative hypothesis correct. All right, good luck to you.